Thank you for the introduction and for the invitation to be here. So I'm gonna approach this from the perspective of the fact that we have lung cancer screening recommendations and the idea that we could potentially add coronary calcium screening on top of that. These are my disclosures. So what we have to realize is that for coronary calcium scoring, we have a very standardized scanning and reconstruction protocol that by now has been around for more than 30 years. It's an ECG synchronized cardiac CT scan in sequential mode or more recently high-pitch spiral, 120 kVp tube voltage, 2.5 or 3 millimeter reconstructed slice thickness, a field of view of 250 millimeters, and filtered back projection. The quantification is according to Eggleston. There are different methods around, but this is the method that has been most consistently used. And when you see calcium score in the literature, this is the way that the amount of coronary calcium was quantified. And from multiple studies, both validation study and prognostic studies, we know that the calcium score is a robust image biomarker of coronary calcium, reproducible and accurate, and very strong predictive value for cardiac events. Now, when we're considering, okay, how can we combine coronary calcium evaluation with lung screening? We have to put these scan and reconstruction protocols side to side. What are the differences? And we evaluated this some years ago. When you look at lung screening, there's no ECG gating. The tube voltage is variable. The scan mode is usually a low-pitch spiral. The reconstruction can be filtered back, but usually is iterative reconstruction to account for the increased noise in low-dose CT. Different kernels are used. The field of view is the entire chest. And of course, we have thin slices, isotropic voxels. So if we're considering to combine coronary calcium and chest CT screening in one protocol, one visit, how would we do this? And we evaluated this, or in a bit of a perspective paper, also including emphysema and air trapping as signs of COPD, as together being called the big three diseases. When you want to do this optimally, you basically need to do a number of scan acquisitions so that you have robust image biomarkers for endolung nodules and emphysema and coronary calcium. But this is, of course, not possible, not in terms of time, but also, importantly, radiation dose. So there are different options of combining these different biomarkers. Of course, primarily, we would like to have just one scan to look at all of these markers. And we would like to have repeated CT scans with the same protocol to reduce the differences and the variability between scans. Now, when we consider that, what should be the aim in calcium scoring that we should be focusing on? Should it be the calcium score 0 or the high calcium score? Well, that depends on the clinical context, but in screening, what we are aiming for is a high, an elevated risk. And when we're looking at different recommendations and guidelines in cardiac CT, we see that a high calcium score is usually defined by a calcium score of more than 100 to consider or start statin. So this is what we should be looking for in coronary calcium screening. So how well can we do that with a chest CT? Well, it's important to realize that both in the detection and the quantification of coronary calcium, the chest CT scan is not as good as a dedicated cardiac CT. Due to motion, you can miss small calcifications, so the detection is lower. And in large calcifications, you'll find a lower calcium score, again, due to motion. A number of studies have directly compared cardiac CT with chest CT in terms of the detection and quantification of calcium. Already years ago, we performed a meta-analysis in this field using the, at that time, older CT scanner generations. We found that in 9% of cases, chest CT missed a positive calcium score, but importantly, 19% underestimated the presence of a high calcium score. Ooh. Right. More recently, and this was a meta-analysis that was published last year that also included new generation CT scanners and protocols with 256 MD-CT and high-pitch third generation dual source CT as the largest studies, found the sensitivity for calcium to be 96%. Agreement of categorization of calcium score categories very good, kappa of 0.84, and misclassification to a lower risk category reduced to 6%. So quite reasonable. Good news. But for each new technique we have in chest CT, we will need to do again validation of detection and quantification of coronary calcium. This is a study that used ultra-low dose chest CT using spectral shaping with a 110 filter KVP scan, and they found nearly perfect correlation of calcium scores. Importantly, we always find that because when the calcium score goes up in chest CT, it's always also higher in cardiac CT, so it doesn't matter much. We have to look at the agreement, which is 0.78, substantial, but 31% ended up in a different risk category. 28% of the high calcium scores were missed. So is this sufficient? That's a question. Of course, we cannot do, again, a cohort study with chest CT, cardiac CT, with each new chest CT protocol. So I think we need to use available phantoms, small calcifications, tiny calcifications, moving phantoms, and we've had quite a lot of experience with that under the leadership of our physicist, Dr. Marcel Greuter. Now, an alternative approach that you'll see a lot in literature is to use a visual assessment of calcium on chest CT. You can use 4 categories: absent, mild, moderate, and severe. You see here 3 examples of mild, moderate, severe. Moderate and severe kind of correspond to a calcium score of 100 to 400 and above 400. So basically, if you can just look at the scan, any kind of chest CT, doesn't matter what protocol, and look at if it's moderate or severe, then you can also select those with elevated risk of events. An alternative, which more scores, is the ordinal score, which was designed by Dr. Schemisch. Now, these scores are fast, reproducible, and you could just do it with any chest CT. But recently, this was checked in a larger study, more than 900 clinical cases with diverse chest CT protocols compared to cardiac CT, and they found quite strong impact on classification. The sensitivity for a positive score was only 76%, and 38% of those with a high calcium score were missed. So is this sufficient for screening? When we look at prognosis, this is good news. Even in chest CT, the increase in the amount of calcium has a strong relationship with cardiovascular events, irrespective of what method you use, Eggleston score, visual ranking, etc. But these are lower than for dedicated cardiac CT scans. Lastly, when we're looking at the recommendations for coronary calcium evaluation in chest CT, we have now 4 documents, including the latest based on, focused on screening, which is a European multi-society statement on incidental findings in chest CT. All of these state that we should evaluate coronary calcium on any chest CT and should estimate the amount as non-mild, moderate, severe. The SECT-STR statement says that it may be reasonable to perform Eggleston scoring, and all of them state that in moderate or severe calcium, we should do refer for review of cardiovascular risk factors. So I think this meeting will be an optimal setting to start a discussion on how we can integrate calcium scoring in lung CT screening. And assuming the goal is that we find those with a high, moderate, or high amount of coronary calcium, we have a number of questions we should be discussing and answering. Is visual scoring accurate and sufficient enough? Also, when we want to look, for example, on follow-up scans, what happens with the amount of calcium? If not, we need calcium scoring. If so, How do we deal with different tube voltages of different CT screenings? Do we need a specific calcium score reconstruction of 2.5 or 3 millimeters, or can we just use the 1 millimeter slices large field of view? Do we perhaps need ECG gated scanning, which will of course really impact the way that we do chest CT screening? And lastly, does ultra-low dose chest CT allow for accurate calcium scoring? Looking forward to our discussion. Thank you.